Here are some helpful instructions for Lab 14, Igneous Mineral Identification. As stated in the introduction, we're going to be looking at physical properties of minerals that are common in igneous rocks. The objectives are to identify 8 common silicate minerals and 2 common accessory minerals in hand specimens. Now, unfortunately, because we're doing an online class, you're going to have to do this through watching videos, and you will not need any of the items listed here to do the identifications. I'll get to how to access the videos in just a moment. You are going to need your mineral identification tables that are in your lab manual and found between pages 148 and 157. Let me remind you about those pages. Here's one of the pages, page 150. And remember that these list the names of minerals and all of the properties across the top for each mineral. And there are 2 sets of tables, one that lists tables with non-metallic luster and another whole set that lists metallic lusters. So even though there's a luster column, the tables are divided between metallic and non-metallic minerals. Each of the 2 groups, the metallic and non-metallic, are then listed in order of hardness. So here we have the softest minerals, and they continue up eventually to the hardest. We have a column with luster. In this case, because these are the non-metallic minerals, they go further and give you an additional kind of description. We have the color of the mineral, and then the color of the streak. And when it says white, that also means colorless. The specimen structure is listed here. Whether there's cleavage or not is listed here. Usually if it's blank, it means there's fracture, which means there's no cleavage. Remember, it's either or, cleavage or fracture. We're not going to use heft, so forget about heft. That's how the mineral feels in your hand. And then miscellaneous properties, which you'll see is sometimes blank. Sometimes minerals don't have any particularly unique properties. And then of course the name, and it says chemical formula, but in this version of the table the chemical formulas are left out. Here are the 10 minerals in this particular lab that we're going to look at. Now none of these are listed on this particular page, but I got a different page and I'm highlighting it in red to kind of indicate that this is a different page. Unfortunately, these headings up top do not repeat on each page, and that's something I'd like to change eventually. So I've left this one up here to see the headings. And here on this page, we do have 3 of these minerals listed. We have a mineral called orthoclase, which is here listed as orthoclase feldspar. It's also called potassium feldspar or K-spar. We have a mineral called plagioclase over here, and that's plagioclase feldspar. And there's a mineral on this page called olivine that's also in our 10 minerals in this lab. So one thing you should probably do is look for these 10 minerals in these charts and familiarize yourself with their particular properties so you can look for them in the videos. Orthoclase and plagioclase feldspar are very difficult to tell apart. They're both feldspars. They both have cleavage fragments or look like square prisms with 2 planes of cleavage at 90 degrees from each other. So they're very similar. They both have white streaks. They have similar hardness. Even though this says waxy and pearly, they both look very similar in their appearance. One significant difference between them is their color. They can both be white. They can both be gray. But only orthoclase can be pink. So if you have a piece of feldspar that's white or gray, that doesn't tell you which one you have. But if you have one that's pink, you know it's orthoclase. Also, orthoclase contains a texture called perthite, which is kind of a wavy texture. Plagioclase has something called striations in it. When you watch the videos, the people that are showing you the minerals are going to emphasize if there's perthite or striations. So make sure you listen carefully for those. Olivine is unique because its color is grass green, and not many minerals are green. Also, vitreous means glassy. The next page has your pre-lab questions. The first question asks you, among the 10 minerals that we'll be studying, only 8 are silicate minerals. The other 2 are common accessory minerals. Which are those? And it says, hint, they will be missing from table 1. So I'm going to show you table 1 in just a moment. Which minerals that we'll be studying will have cleavage? So you'll look on those tables I just showed you from the back of the lab manual, and you'll be able to tell which ones have cleavage. Which minerals will be magnetic? That will be given in the miscellaneous properties column. Will any of these minerals be metallic? Well, again, you want to go to the metallic luster part of the table and see if any of the minerals are listed there. Which of these minerals will be harder than Mohs value of 5? Then you go to the hardness part and check if any of these minerals are harder than 5, and you can see that there's 3 of them right here. So that's pretty straightforward. But let's take a look at this table 1. Table 1 lists 8 common igneous rock-forming minerals, not the 2 accessory minerals. So that should make that first question really easy. This table divides these 8 common igneous rock-forming minerals into 2 groups. And I've mentioned these 2 groups in a previous video. Mafic, which means rich in iron and magnesium, and felsic, or sometimes called silicic, rich in silica. Mafic minerals have magnesium and iron, one or the other or both, and you can see that all of these have that. Silicic minerals, rich in silica, are missing iron and magnesium. Now the silica isn't listed here because everything has silica, but they do not have any magnesium or iron. One way to tell these apart in hand sample is that mafic minerals tend to be dark in color. And notice that olivine is here. I said olivine is green. We're going to consider green a dark color. Felsic minerals tend to be light colored. You'll see that there are 2 plagioclase sub-names here, albite and anorthite. Don't worry about the difference. First of all, you can't tell the difference in a hand sample. You need to chemically analyze the mineral to see which one is sodium rich and which one is calcium rich. It turns out that the calcium rich ones occur in rocks that are mafic and have mafic minerals. And we'll get to igneous rocks next week when we talk about mafic rocks and felsic rocks. So that's listed there just, I guess, as a preview to rocks. But for now, don't concern yourself about that. You're just going to identify plagioclase. The next column talks about the silicate structure, and this is also not something you can see in a hand sample. I talked about silicate structure in the video called MINS 5A.5, so if you want to remember where I introduced that concept, that's where I did. And then this is just repeating some of the information in the main tables, the cleavage and hardness details. And then this is associated minerals that occur in igneous rocks. So again, this is a bit of a preview of what we're aiming towards next, because by mastering the igneous minerals, we're going to move on to rocks and look at these minerals and how they associate with each other in certain rock types. So that's table 1. Now let's look at where to find these videos online to help you identify them. First of all, here is our module page. At the top, you have projects, mineral and rock videos, office hours, orientation, etc. So you're going to go to the mineral and rock videos, and when you open it, you're going to see these 4 options. The Phys Geo Mineral videos is what you use for your hardness mineral lab, and that's where you're going to go. Next week, when we look at igneous rocks, you're going to go here. And when you open that Phys Geo Min videos, which you've already done, you can either download this as an Excel file, or you can select individual mineral numbers. If you scroll down a little bit on this page, I'll show you that 1 through 10 are here. So you just click on whichever one you want to look at, and then you'll see a 1 to 2 minute video. So I'm going to click on number 1, and I'm just showing you some snapshots from that video. First of all, this one happens to be 2 minutes. She talks through the whole video. She rotates it around to show you various flat faces that are at 90 degrees, so that's a hint on something there. She's pointing out something in the texture here. She does a scratch test and mentions something about the hardness here. She doesn't talk about the luster or the color. Sorry, I have luster in there twice. So you have to realize this is not metallic, and you have to realize this is sort of a pink or a salmon color. So not everything is going to be spoken in the video. Some of it you have to see and you have to realize. So then you're going to put that information for number 1 in here and eventually figure out what the name of that mineral is. And you're going to do it for all 10 minerals. Now, I want to make sure you realize, because sometimes students make this mistake, this is not the list of the 10 minerals in order from 1 to 10. Okay? In other words, augite is not number 1. biotite number 2, hornblende number 3. That's not how it works. This is just an alphabetical list. You have to figure out which of these is number 1, which of these is number 2, etc. Okay, so students commonly make this mistake, especially the first time we do this. We're going to be doing this for a lot of minerals, but this is our first mineral lab. So just realize these are scrambled in terms of the order that you're going to be coming up with here. Finally, there are the post-lab questions. These first 3 post-lab questions, I think I pretty much answered for you when I talked about Table 1. You should be able to get those answers pretty quickly. And let's look a little closer at these last few questions. I've highlighted in blue that I'm asking you to look up the concept of mechanical weathering and chemical weathering and talk about which minerals are most susceptible to being broken down by these processes. So you have to look up what mechanical weathering means. And when it comes to chemical weathering, I'm suggesting that you search for chemical stability of minerals and look for images where there's charts that show different minerals in order, increasing or decreasing stability of chemical breakdown, of susceptibility to chemical weathering. We're going to talk about Bowen's reaction series next week when we talk about igneous rocks. However, there's a very brief discussion of Bowen's reaction series in your textbook, Chapter 4, Section 4.2. So you could read that and you'll find out the answer to this question very easily. So remember, try all parts of this lab. You will not get graded on the basis of whether you identify the minerals correctly or not. You'll only get graded on whether or not you try everything. Good luck, and come to my office hours if you need help.